right, so just a quick little video on finishing up today's notes. So this was the notes from day 11. We didn't get a chance to do these two problems. So again, to remind you, this is like 7.2. And these are some of the questions from 7.1. So I'll start with 7.1 just because I feel like that's the order that we'll go in. And then I'll make two different videos, one on doing these two problems and one for these. All right, so I'll just start with the easy one. This one looks like distributive property, and that's exactly what it is. So distributive property is multiplication when you multiply the numbers on the outside by the numbers on the inside. So remember, we multiply things that are alike. So this whole number out in front seems to match this whole number here. So 7 times 2 is going to give me 14. And I'll bring down the root 2. So if I double what I have here, I have 14 instead of 7 root 2s. And I'll do the same thing with this. Here again, I'm matching the parts. So 7 and -3 form a -21. And when I multiply this by this, not only do I have to multiply the 7 and the -3, but I also have to multiply the root 2 with the root 5. I didn't need to do that here because this 2 didn't have a root with it. So 7 root 2 times 2, I only multiplied the 7 and the 2. But here, when we've got two components, the matching parts get multiplied together. So root 2 times root 5 is going to give me root 10. So 7 times 2 is 14. Bring down the root 2. Repeat with 7 and -3, giving me my -21. And root 2 times root 5 gives me a root 10. And that's my answer there. So remember, when you're multiplying, you can only multiply matching parts. And you can do that. So whole numbers get multiplied together. Roots get multiplied together. If something is missing, then things just get brought down. But things can be multiplied here, just as is written. That's a little different than this question here, which we might be inclined to do something like this. But you can't just subtract those together. Those are addition and subtraction works a little differently. And I can prove it to you. If we just tap in root 24 minus the square root of 6, I think that was it, we get this answer here, which is 2.449. And then if I tap in root 18, if those truly were the same, then I would get the exact same decimal, but I don't. So I can't just subtract things that are not the same. Multiplication's a different game. With multiplication, you can just go out, just do the problem as written. That's totally fine. But addition and subtraction requires a little bit more work. So I can only subtract things if these two numbers match up. And so since they don't, you might be inclined to write like, oh, no solution, that one doesn't work. But as we've examined in the past, you can break down 24 into two numbers that multiply together. But you want to pick strategic numbers. So I can pick 12 times 2. 12 times 2 is 24. But I don't know what to do with root 12, and I really don't know what to do with root 2 either. So that was kind of a bad strategy. So I'm going to try it again with two different numbers. So the combo that I can think of that gives me 24, besides 12 and 2, is 4 and 6. And that's actually a really good strategy for two reasons. One, I know what the square root of 4 is, and that's 2. And I don't know what the square root of 6 is, but I do like that this number matches that number, and that's going to be pretty important. So what I basically did was I took that root 24, the bigger number, obviously, because you can't, you can break down 6s, but you have a better chance of breaking down bigger numbers. And I broke it down into two numbers that after you plug them into the root, remember they have to multiply to 24, so you can do something with them. Since I know the square root of 4, I'm going to write that answer down, and then I'm going to carry the root 6 down. So root 24 is replaceable with this. So now I'm going to write this here. And remember, this root 6 isn't going to make this one disappear. It's just saying I've got two root 6s, and then I've got secretly a 1 there. So I've got two root 6s, and I'm taking one of these root 6s away. So if I have 2 root 6 minus 1 root 6, this is my final answer. And that 1 doesn't have to be there. So it's the same thing as this, like 5 root 7 minus 2 root 7 would be 3 root 7. If you have 5 root 7s and you take 2 of them away, you just worry about the front number being subtracted and you leave the root part alone. So 2 root 6 minus 1 root 6, that's where I got this 1 from. But again, that 1 doesn't need to be there. Okay, and just as a little extra, again, if you've got a really big number here, you're like, I wonder what I can do with that. You pick 2 numbers that multiply. 5 times 10 is 50, but can we do anything with that? I don't know what the square root of 5 is, and I don't know what the square root of 10 is, so I'm going to pick 2 other numbers. So 25 and 2, the square root of 25 is 5, and that's my answer there. All right, so you can do that anytime you've got 2 roots that don't match, is try to see if you can break this number into 2 numbers that multiply to this number here underneath the root, that you can evaluate and turn it into a smaller, number. That way you can get these 2 things to match up. That's the plan. Okay, hope that helps.